Hello, my name is Valera. I'm an engineer at a company called Slack. And I joined Slack in January 2016. And I'm going to start off by telling you about this amazing transformation that I witnessed as an engineer at Slack in the last 2.5 years. So when I joined as a regular Android feature development. Before that, I was working on tooling, and I wanted to try out the feature development thing. I now know that it's not for me. Back in those days, Slack was all about shipping features. We were in this kind of mad rush to release all the functionality we can before our competitors catch on to the fact that this is actually a pretty good business. And so, it was just basically hack, and release to production. I don't know. This is what I thought of when I thought of hacking and releasing to production. I too like to live dangerously. By the way, I've never seen this movie. Is it actually good? All right, I will watch it at some point. And this is actually okay, and especially considering that when the founders of Slack were pitching to investors about this idea of Slack, apparently the slide deck included this slide that said that Slack is a product that is built for teams of at most 300 users. Raise your hand if you're currently on a workspace at Slack that it has more than 300 users. All right. And some companies actually apparently have tens of thousands of Slack users, amazingly. And many of them, are on one workspace. So there are now, slightly different scale. This is another kind of picture to demonstrate that. Back in about like 7 months after, or actually, sorry, more like, when is October? 10 months after I joined, we were at like 4 million users. You can imagine, this has grown ever since then, and the growth has kind of never stopped. And so the idea of simply hacking, and releasing to production and shipping as many features as possible was getting a little bit dated. And finally, the CEO wrote a Slack post that included this phrase in it. And despite the profanity, it was pretty effective, or maybe thanks to the profanity. And a bunch of engineering teams rallied around this cause of performance. And they just went out and fixed all the performance bugs. That's what you do when your CEO tells you to fix all the performance bugs. And this is fine. This kind of what we call surge, or whatever you want to call it, is a good way to sort of pay back some technical debt. But performance bugs are slightly different than maybe other kinds of bugs. They're quite subtle. And they're not always noticeable. In fact, like your users may get kind of like slightly annoyed, like you would by maybe a slow elevator in your building. But it's not like a complete outage or anything. It's just going to be like slightly annoying, and things can kind of just get slightly worse over time until you're in like this situation where the product is not very usable and it's super annoying, but you don't know exactly what happened, how you ended up in this situation. And so I came from a background of test automation and engineering productivity. And I thought, well, once we do fix all these performance bugs, what's going to happen after that, right? Eventually you're going to end up in the same kind of situation. Unless you have a system that allows you to work sustainably, and really allows you to shift the way that you do performance type work. And so I started thinking, like, what do we actually need in order to make this happen? So first of all, we need to be able to see kind of throughout the history of as we merge things to master, when at one point things got slower, or actually when things got faster. That would be nice to see too. So we need trends. And ideally, this is as granular as possible, so we need trends for like every single merge to master. And this, by the way, actually gets you a lot already. Like once you have this, you can just have certain engineers looking at these trends being curious because people love looking at charts. I'm sure you're all analyzing this chart as we speak. And we have this, actually at Slack, we have this guy named Kevin who does this really well for the backend team. And he just looks at all sorts of charts, asks questions, and then finds a lot of problems, and then people go and fix these problems. But I wanted to see how we could automate Kevin. And so, of course, we would do that with some kind of alerts. Like, we actually want to receive an alert when things got faster or slower. This is cool. Alerts are awesome. Not super novel. But we wanted to kind of go a step further, actually. When I presented this idea to our CTO, he said, well, why can't we do pre-merge alerts? Like, that would be really amazing. I mean, we do this for functional tests, right? We block our merges if our functional tests don't pass. What if we block merges, well, or at least notify people that something is getting slower or faster before they actually merge their code into master? That would be amazing. So how do we do this? If you kind of just stop a random person walking around Soma and ask them how you would automate this, okay, don't do it in Soma because you'll probably get someone who actually works on performance testing, but maybe in like Berkeley or something, this is what they would tell you. You would measure the development version value. You would compare it against the baseline and send an alert if they're different. At this point, you may be wondering, what is a value? A value really can be any number. Our main focus is on execution timing of key customer scenarios. But really, it can be anything. For example, frame metrics is a pretty good thing to track, resource usage, and really anything that can be measured and that you actually care about. And then the baseline is simply what's kind of at head and master. So that's pretty naive, and nothing wrong with this approach whatsoever, except that we have a problem. Unlike functional testing, where everything is either green or red, in performance land, results are very variable. Sometimes very, very variable. This is actually an Excel spreadsheet that I made before I kicked off, and like started actually building any automation. I wrote a UI test that dumped a bunch of performance timings in our app, and I just put it into a CSV file and charted it. Looked at that graph and I said, oh my goodness, this is like not workable. How are we ever going to be able to get any useful signal out of this? But thankfully, we have smart people working at Slack, and some of them do data analysis and are statisticians, and so they suggested that I use this thing called statistics. I'm not a fan of statistics in college, but I took the class. I am a much bigger fan of statistics now. In fact, I think it's a pretty useful thing to know. And so in statistical approach, what if instead of gathering one data point, imagine this: we gather a set of data points from our developer build and the master build, and we compare these two sets. And so in this approach, we would take a median of our data set, and that's what we would trend. That's what we would sort of display in our trend. And then the comparison would lead to an alert if something was different. And for this, we use a statistical test called the Mann-Whitney U-test. It's a pretty cool thing, actually. I wish I didn't have to hold this microphone so I could gesture more. But you can take two data sets, and essentially the Mann-Whitney U-test analyzes the overlap between these two data sets. And the more the overlap, the more similar they are. So essentially, the Mann-Whitney U-test gives you this thing called the p-value. And the p-value, the inverse of the p-value, essentially in human terms, is confidence. Confidence in how different, how confident are you that these two sets are statistically different. So a statistical approach would look something like this. We collect a set of n values from the dev version, test it against the data set from master, and then we alert if the confidence exceeds a certain threshold. So notice two things. There are these two variables here that I didn't define, n and threshold. And we actually control these variables. So this is pretty interesting because we can play around with this. The higher the number of values that we gather, the better, for lack of better words, better stats we get. Statisticians always want more data points. And there's actually, you could calculate like the exact number for a certain confidence. And the higher the alert threshold, that means you'll get a lower false positive rate. But there's kind of, it's not all free here. It's not all simple. First of all, if you want to gather more data points, that means you need more devices. You need to run your test more times. And higher alert threshold means that you'll have a lower chance of valid detection. You're essentially like, if you dial it all the way up, you might miss some things that were actually true. So interesting observation, keep that in mind as we build out our system. And finally, one last thing is, who are we building this for? So I'm a big proponent of quality being owned by developers. By the way, this is the second time I give this talk. The first time I gave this talk was on an iMac screen, and there was a person that said, please don't show a video of Steve Ballmer like jumping around on stage, because it would be too scary and too overwhelming for people. So I debated whether to show a video here, but I decided not to. And what does that mean for our system? Like, what does the fact that we're building this for developers actually mean? Well, in order for developers to sort of get value out of it, they need to trust the system. And in the terms of the system, it means that I define trust as valid detections over noise. So essentially, the more things we can detect, that's great. But if the system is really noisy and gives us a lot of false positive, well, that kind of lowers the trust. And I would kind of venture to guess that as a developer, you actually care mostly about noise. Like, if the system, is not noisy at all, but it's not catching anything, well, okay, it's just running in the background, causing no harm. That's fine. The minute it starts being noisy, that's when you really lose trust with the developers. So that's, in a nutshell, the system that we want to build. That's what we want to build. Now let's look at how. Of course, it all starts with a developer sitting on their MacBook Pro, I believe. By the way, interesting thing about Keynote, they have the Apple emoji set. There are no Android devices in there. It's all Apple devices. It's, it's part of their emoji set. So of course, it's a Mac machine. And this developer wants to merge a change, well, actually it does merge a change to master, all the checks passed. That goes to GitHub. And if you have some kind of a CI pipeline running, like Airbnb does in their previous talk that you saw here, this is going to basically trigger some kind of a job, or maybe a set of jobs. For our case study here, this is the performance testing job. And this performance testing job is going to run some tests, gather some data, ship it to a backend. And this completes sort of the first part of our system. From this backend, from the SQL database where we stuff all the data, we can make these trends. So that's the first part of the system. But there's a second part. There's a second developer, Clicker, who opens a PR. And again, GitHub has webhooks and detects that this event happened and kicks off the same performance testing job. All the same stuff runs and uploads to the backend. And this time, the backend can detect the fact that this was a PR job and can decide whether to alert or not. Super, super easy stuff. So there's a lot that obviously goes into this, and I'm going to go into each one of these in detail. I do want to sort of make one caveat here. There's so much information. Even when I started writing the blog post, I was overwhelmed. So I just selected some kind of tidbits that I thought were most interesting. So obviously this doesn't cover it all, and don't blame me if you think it's not that simple. So let's look at the performance test job. So again, we start with a naive approach. I always like to start with that. It might look something like this. We use Jenkins. A lot of you probably use Jenkins here. So there's always some kind of a build node, whether it's a virtual machine or a local build node. And you might hook up a physical device to it and then just basically start running tests on it and ship it to a backend. But of course, you want things to go faster. Again, developers are waiting for these results. Remember, we want to do this pre-merge. So, at this point, we're going to add more devices. We're going to parallelize our runs. And maybe at this point, we're going to say, hey, this is kind of silly. Let's abstract away the sort of the physical device stuff and maybe put it behind this device provider interface. and your runner can just get devices and release them to the device provider. This is what we started with. And if you notice one thing here, we're dealing with physical devices. So, of course, ultimately, we end up building a physical device lab. Looks like this. This is a slide that I've been showing in all of my presentations since 2011 when I was working at Google on Google Wallet. And a recent kind of achievement unlocked moment for me was this slide was used in the Android Dev Summit for the testing talk there. So if you watch one of the testing talks of the Android Dev Summit, you'll see my slide there. But I built this thing. It was great until like the Velcro on the devices melted and the whole device lab went, collapsed. So what's wrong here? Just don't even attempt to do this if you want to sort of do performance testing or build a performance testing pipeline at your company, unless you actually have the infrastructure and the resources to build something like this. This is a screenshot from a blog post that Facebook released a while back, highlighting how complex it is to actually build a proper device lab. So if your company doesn't have the resources, doesn't have a data center team, and can't like rack phones this way, I really suggest that you don't waste time on sort of local device testing. You're just going to run into all sorts of problems. So with the cloud version, okay, I obviously skipped ahead. You want to move things to the cloud as much as possible. For us, that means using Firebase Test Lab, but there are a number of cloud device providers where they can allow you to run tests on devices and receive back some results. I really suggest that you go that route, at least as a start, until you have a data center team. The cloud gives you two things. So it gives you stability. We used to deal with all sorts of, even before you get to the variability on all the data stuff, like device would just go offline, right? And or a USB cable would go bad or something like that. All sorts of instability would happen. So cloud device provider gives us stability. All of that is taken care of. And it's also much easier for us to scale, or at least it's easier for Firebase Test Lab to scale device testing than it is for a team of like 3 or 4 people at Slack. But it's not all rosy. With a cloud device provider, a third-party device provider, we use some amount of control. And just to demonstrate, the control part or the loss of control part, I have a story that I'm going to attempt to tell. You may have, how many of you remember this? So this was a presidential alert that was fired off to all phones in the United States. And there was no way in hell to actually dismiss this thing other than by clicking on it. And so the Firebase Test Lab actually had a 2-hour planned outage because of this. So they, Trump literally brought down our testing pipeline for 2 hours. Yeah, I can just imagine some poor Firebase Test Lab engineer walking around their data center and clicking all. I hope they had a better way. I don't know. But apparently this is not a trivial problem. By the way, another non-trivial problem was finding a screenshot with an Android phone and not an iPhone with this alert. Google it right now. It's hard. So you lose control. Other things that can happen is, for example, Firebase Test Lab decides to roll out a new version of the OS on all the devices for a certain API level. There's security patches and whatnot, and that can affect performance. So all of a sudden we start receiving, all sorts of noise and seemingly coming out of nowhere until we find out that that's what happened. So there are disadvantages to cloud device providers. And even with the cloud device providers, unfortunately, you still hit scalability issues. I mean, it's amazing. It's interesting because when we think of AWS and Google Cloud solutions, we think of unlimited scalability. But with physical devices, it turns out that even Firebase Test Lab has an issue with scaling. So sometimes we hit those limits, and our tests get queued up and take an hour or 2 to run instead of 7 minutes. And so really, this is not the same thing as this. And I think that at least for the foreseeable future, maybe in the next 10 years, we're going to live in this reality where, unfortunately, we do have to think about the limitations of like physical device testing. That's why, for functional testing, I say forget about physical devices. Always do it on like virtual devices. But for performance, unfortunately, we can't do that. Emulators just don't work well. They don't give a good signal for performance testing. So that's the CI part of the world. Let's look at what are we looking at next, the device. What happens on the device itself once we do have a physical device available to us? So on the device, we have two things running on the Android operating system. We have our application, which is instrumented to scrape performance metrics. And we have an instrumentation test. It's not the same instrumentation. It's instrumentation that's part of the Android framework, which drives our app, essentially. It's a UI test that just drives screens in our app and hits like key customer scenarios. And the only thing I'll say for instrumenting your app, we could have a whole talk about how to instrument your app properly for performance, but you could start very simple, and I think you get value out of this by simply just recording start and stop timings and dumping them to like a CSV file. And on the instrumentation test, essentially, as I said, it exercises your app. You probably want to focus on like the key customer scenarios first, and then at the end of the test run, it just, since it has access to the entire sort of process, it can just get at these metrics and dump them to a CSV file. So the next thing here, I'll kind of mention a few things that we've learned as we concentrated on this part of the pipeline. This is actually a pretty critical part of the pipeline, and it's hard to get right. So number one thing is focus on the client. What does that mean? First of all, the network is already highly unstable as it is, and it's also highly variable. If you've ever like measured, network response times, you'll know this. And even if you were able to like get a perfect network that's like perfectly consistent and reliable, you don't want network like backend sort of regressions to block your client developers from merging their code, right? They're going to be super pissed if you do that. So you want to focus on the client. What that means is use record and replay. We use a library called OK-Replay, which coincidentally was just mentioned in the previous talk by Airbnb. And I'm proud to say that we have as many tests using OK-Replay as Airbnb does, which have one performance test right now. We're going to get more, though. So, this simply records network responses as you run your test. So there's a record mode, and then there's the replay mode, which replays them and takes the network instability and variability completely out of the equation. Unfortunately, oh, sorry, I skipped ahead. So the number two point is keep it real. We want to catch regressions that kind of are similar to what our users would see in the real world. What does that mean? That means that we want to preserve as much as possible our application graph, and we want to run against a release-like config. And this is kind of another contrast between functional testing and performance testing. In functional testing, we are totally okay like mocking out parts of our application graph and swapping them out so that we can focus on like the UI layer and make our tests smaller and more stable. But I would say that for performance testing, you want to maintain, unfortunately, the entire app graph, or as much as you can, parts of the app graph. And unfortunately, that means that you end up with a large test. That test is hard to maintain because it hits a lot more code, and there's a lot more things that can go wrong. So the next problem you'll have is, how do you make this thing stable? Your performance test will be, or hopefully more than one test, will be executed a lot. And I mean like a lot of times. Remember that N value. Sometimes maybe we want to scrape like 100 data points from a single dev build. So the stability bar is very, very high. It's much higher than actually it is for functional testing. If your test is like 99.99% stable in functional test land, maybe that's okay for CI. I would say no, but some people would consider it okay. For performance tests, this would be unacceptable because your rate is just going to half of your builds are going to fail. So I would say, you can build sort of solutions to work around this. Like you can sort of retry more times and do all of this, but that's a slippery slope. We instead chose to not compromise on flakiness. And we spent a lot of time making our tests very, very stable. One of the things that really helps with this is in Espresso test framework, there's a concept called the idling resource, which will synchronize parts of your application with your UI test. And I don't really recommend using this for general functional UI testing, but I do recommend using it for large tests like end-to-end and performance. And once you make your test stable, one very important part of this is keeping it working. So what do I mean by this? You really want to make sure that you block merges if developers make changes that break your test. And I didn't do this before because I wasn't like 100% confident in the stability of our test, and I ended up being like this. It's not a pleasant experience. I mean, you're just having to constantly like fix the same test over and over again. So one thing that we've done that's actually solved this problem completely is we run our performance testing on physical devices, and for scraping timings, but we also run it as part of our functional test suite, so that any sort of functional change will actually block merge. Very important point. So that's what happens on the device. Let's look at the backend. I'm not a backend person, so this is going to be like very trivial, probably not interesting. But let's look at it anyway. Our API is super simple. We have two APIs, one that creates a performance build and one that completes a build. We could probably merge this into like one API, but we wanted to sort of have a quick way to fail at the start of a build before we start running performance tests, in case we detect like a duplicate build or something. So that's why the create API is there. As I said, it runs some sanity checks, creates a build in the database, and then finally, when our performance test run is complete, we hit the complete build API. This in turn runs all the analysis and stores the data in the database. And at the same time, if it's a dev build that's being analyzed, it can send a Slack alert. So super simple. Some of you maybe, or actually, sorry, one more quick thing. Perf data, how does the sort of data look like? It's pretty simple. There's some metadata at the top that allows us to, for example, alert a developer or do the pretty trend line by PR number. And then there's the actual perf data itself. So it's like pretty trivial, JSON stuff. Some of you may be wondering which backend stack we use. I would say, as great as new shiny technology is, just go with whatever stack you have in-house already, if you do decide to build this pipeline. I think there's a big advantage in just having developers, like backend developers, being able to contribute to your code base, and at the same time, you don't want to maintain this stuff. You want your ops team to do it. So just use whatever you have in-house already. That's all for the backend. Now let's look at the really fun part. This is the sort of the UI layer and the developer experience of the system. So first of all, the trends. I want to highlight a few things here. As I mentioned, we want to do this on a very granular level, and you'll notice that our builds here are ordered by Jenkins build number. Why is that? It's sort of not very, developers don't even care about Jenkins. Why are they ordered this way? The value on the x-axis here has to be monotonically increasing. So, PR numbers, for example, are not merged in the exact order as, as the number would suggest. And they're not monotonic, right? Like if you didn't have sort of a monotonically increasing number, your graph would kind of look really weird. So Jenkins build number so far is the only build number that I found to be like in order and sort of like always increasing by 1. Next thing, you'll notice this little sort of green, hopefully on the screen you can see it, this little green tick there. One of the things that one of the kind of ways that we measure the quality of our system is we look at all the changes that have happened in the trends, and we see whether we actually sent an alert. So this actually does show you that, hey, we sent this alert, and then at the bottom we'll actually like display which alert it was, and give you data on like to be able to follow up and actually look at that build. This is pretty useful if you're just going to go back in history and start asking, like, oh, why did this trend change? Did we send an alert? So now the alert itself. You're probably shocked, but we send an alert in Slack. So this is a Slack message, essentially, or a Slack app. By the way, our project code name is Honey Badger. We haven't come up with anything better. If you have a better name, please come up and suggest it at the end of this presentation. And this alert, you'll notice, has some metadata at the top. So it mentions the developer, the PR author, the PR number, and then gives you a link to the PR. This is actually really useful because most of the time you're going to be looking at this, and if you trust the fact that this is real, you're going to look at the code. So that's why the PR link is there. And then at the bottom, we display which metrics got slower and faster. So one kind of element of the system is that we don't only care about things getting always slower. We actually want to reward developers for performance work, right? Like if they're doing performance work, we want to send them this awesome thing that says that they're making things faster. Then we have a link to more details, sort of expanded details for the performance build. And there's a lot of stuff there. I'm not going to have time to show all of it. But one kind of very useful thing that we found is your current development value against the trend in master. And you'll see that, with just this simple visualization, we can see that this was probably a real alert because the current development value is way outside, well, not like way, but it is slightly outside the historical range. If it wasn't outside the historical range, it would look something like this. And this would probably mean that this was a false alert. At this point, you might be asking yourself, well, why don't you automate this? We can detect it visually. And that's a very good question. I think we should automate this, but it turns out it's not so trivial. Once you kind of move away from the A/B test pattern and you start looking at historical trends, it's really hard to determine what should the window be, and when the trend changes, was that like a real change or a false change? So statistically, it's actually a non-trivial problem, and so our smart stat people told us, just do A/B testing for now and display this just as a helper. A human is just sometimes better at judging than a machine. Also, it could be an interesting application for machine learning, right? In theory. And then more on debugging. One kind of really nice property about pre-merge alerting is that it's great for experimenting. Let's say you have a hypothesis, hey, I'm going to make this faster. You don't have to merge that hypothesis and wait for your app to actually release to users to actually see that it got faster. You can experiment with this locally by just basically shipping it, just by opening a PR, in fact. And then if you make things slower, you can experiment with fixing your regression. You can say, oh, I got this alert that says it's slower. Okay, I'm going to fix it, push another commit. Boom, I didn't get an alert. Everything is great. So pre-merge, it's really, really nice. It's hard to get it right. It's hard to scale sometimes, but it's a very nice thing to strive for. One other thing about developer experience that would be super nice, I'm talking kind of about future work here, is that sometimes when you get an alert, you really have no idea why that code made things slower. And it would be really nice to just show the developer, well, here's exactly in your code base or in the stack trace, here's where things got slower. So eventually we'll look into detailed trace info. And for this, there's a library. Again, Facebook does a lot of great performance work. And there's a library called Profilo that looks really promising. It's kind of a lightweight tracing performance trace gathering mechanism. They run this thing in production and also in their controlled environment. And we're going to check it out at some point. And then finally, in the alert, you'll notice this thing at the end. We actually sort of mention the developer and say, hey, you got an alert, yay. What is this actually, where does this come from? So actually, before you see that previous screenshot, we have a micro survey that asks the developers, is this a real thing? Essentially, there's 3 choices here. Hey, it's a good catch and I'm going to fix it. It's a good catch, I'm not going to fix it, I don't care. I'm going to ship it. Sometimes if it's a performance improvement, it's not even a problem. And then it's unrelated to my change. And this unrelated to my change is basically noise. Like we want to minimize the number of times the developers hit that button. So that's the performance testing pipeline in a nutshell. As I mentioned, there's a lot more to it than that, and I'm happy to chat to you after this presentation. To me, kind of, we've had this thing up and running for about a year, and it's not like a continuous effort by a full engineering team, unfortunately. So we work on it sort of part-time-ish. But we've been able to detect real performance regressions, and we've been able to detect real performance improvements too. This is just kind of this just made my heart melt. So somebody says, hey, y'all, honey badgers, amazeballs, blah, blah, a bunch of performance conversations. This is really like a system that makes developers have conversations about performance. And I think that's a big win already. Unfortunately, we're not fully there yet. If you remember talking about developer trust, when I gave this presentation about a month ago, I was feeling super great about the system because we had caught a bunch of awesome things and the noise was low. And all of a sudden, our system started getting noisy. And I'm not really sure yet why this happened. I haven't had time to actually look into it. But as you can see, we have in the past 3 months, about 1% of our alerts were noisy over just the number of builds tested. And that's far, far from ideal. I don't think that if you ask kind of a Slack developer, Slack Android developer right now, whether they fully trust the system, they will probably say no. So, we have our work cut out for us. There's still a lot of stuff that we can do. And if there's one takeaway from this whole presentation is, if you decide to build this type of system in-house, make sure that you know what you're getting into. This is a lot of work. And this isn't something that you can simply get done and then kind of forget and put in maintenance mode. This system has required a lot of attention and a lot of debugging and a lot of analysis. Coincidentally, as many other companies in the Bay Area, we're hiring. So if you're excited by this, come work at Slack, and you can work on Honey Badger and making performance testing a reality at Slack. And I believe I have some time for questions. So I'll leave it at that. Thank you. Okay, I'm going to start from you. So you're in the front. Currently, we run 31 attempts on every build. It's just a sort of, it's a balance between, as I said, device time, and the requirement for how many devices we need or how long we want to run the test, and something that gives us a useful signal. One thing that you'll notice actually when you start doing this type of work is that certain metrics are a lot noisier than others, a lot more variable. And so ideally we would actually have alert thresholds per metric, and maybe for some metrics we want to gather more data than others. It goes off to Firebase Test Lab, so every attempt is run on probably an individual device. We don't know how they get recycled, but it's an individual invocation. Okay, I'll remember to repeat. The question was how many attempts we run per build, as you might have gathered. So, all right. Okay. So basically, which solutions would you recommend for somebody who doesn't have the resources to build this stuff in-house? We actually started off using NimbleDroid, and we got pretty decent signal out of it. It wasn't perfect. It was also pretty slow. It wasn't something that we could run pre-merge, which is why, and at that time it didn't support iOS, and we wanted to support iOS. So we decided to build it in-house, but I believe NimbleDroid is still around. So I would probably start by checking them out, and maybe other third-party device providers. Or sorry, there are third-party solutions that do this. So I would definitely. It also tends to be kind of expensive, I believe. So there's a sort of cost-benefit analysis at that point. Right. Yeah. So the question is, how much of this is reusable for other platforms? It's a great question. I mentioned we're working on an iOS solution. So essentially, the CI part, the runner, is pretty much the same for iOS and Android, and then the backend. The backend can actually really the backend doesn't care. You give it 2 data sets and it just analyzes those 2 data sets. So the backend can actually support any platform. We had an experiment where we tried out our web app, using the system. So really, the only part that is platform specific is the test itself, I would say. Yeah. The question is, did we consider using emulators as a proxy signal? I did consider it at the start. I really I had this question. Well, why I want to use emulators, of course, but when I ran, that first test that you saw in the Excel spreadsheet, I did not get good data out of the emulator at all. And the one thing that I've noticed about performance work is that a lot of it tends to be related to I/O. So and emulator I/O characteristics is really not the same as physical devices. So if you want to actually get user kind of realistic signal, then I would say you're stuck with physical device. The question is any part of this considered? Have we considered open sourcing this? I have considered it for sure, but I'm not going to make any promises because we don't even have time to maintain it in house right now. So it's I would love to eventually. If y'all come work with us and we double the size of our team, we can consider it. So the question is, how much maintenance does this require once we had it up and running? I mean, it's very variable. I would say, we're in the middle of this a little bit of a crisis right now, where it just got noisy all of a sudden. For a month, it was running and everything was great, and then all of a sudden something happened, and I suspect it's related to actually Firebase Test Lab. I talked to some people there, and it turns out that physical devices are not this infinite resource, and they age. They have to take them out of production, and we're running on a Pixel right now, so Pixels are actually getting harder and harder to come by. I suspect that maybe some of those devices got slower, and we're just getting a lot more noise. So I wouldn't say it's not like a full-time job for one engineer, but sometimes in some periods of crisis, I'd say it's just hard to debug stuff. There's so many moving parts. That it's sort of I would say, if you want to be successful at this, my guess is that you will want to sort of have this fully staffed by a team of 2 to 3 engineers. I think this is, if you read the Facebook blog posts on performance testing, they went a step further, and they have a physical device lab that's specifically tailored for performance work. That's the amount of effort you'll want to have if you want to have a reliable system. Yeah. The P95 values, you mean P90? So we just started running this test, and actually we're not even alerting on it yet. But I think we're gonna measure the P value. So P50, P75, P90, P95. Does that answer your question? Oh, and I forget to repeat the question. The question is about frame metrics. What do we actually measure there? Yeah, so we're gonna I think dropped frames is what we're gonna measure. So yeah. But I really, with this system, the nice property about it is that you could just pipe whatever into it and just see where you get useful signal. So we are not at the point yet where we're even analyzing where we get useful signal with frame metrics. The question is, how big is the Android team at Slack, or the mobile? Roughly, I would say we have 30 engineers on each platform. So that includes sort of the infrastructure team that doesn't do any UI development, and then as far as feature devs, I would say maybe 20-ish on each platform. And then the size of my team is 6 to 8 people, which my team sort of does tooling for both platforms. I think it's time. I want to make sure I don't hold any of you. So the rest, if you have questions, just come and talk to me after the talk, or Twitter me or whatever. So.